Okay, we're going to try this again since I already did it once. So I'm going to be explaining the excitation, contraction, coupling. Okay, so I already drew it out, as you can see, because I had tried to do it once, but I messed up. So here we're going to start with the action potential that's going to come from the brain into the axon terminal. So here, action potential going all the way through the axon terminal and the motor neuron and into the muscle fiber, which is down here. As you can see, we have the sarcolemma right here. So action potential is going to come all the way down to the end of this axon terminal where it's going to release acetylcholine. So this acetylcholine is going to be released into this neuromuscular junction, which is the space between this axon terminal and the actual muscle fiber itself. And it is going to bind to these receptors on the sarcolemma. So this is basically the outside of the muscle cell. Here we go. And so once these acetylcholine binds to these receptors, it's going to then allow the release of these sodium ions in all throughout this muscle fiber into the T-tubules, as you can see here. So this sodium is going to release all into the muscle, all down the T-tubules, all of that good stuff. And then we're going to hit a few receptors along the way before it gets to the sarcoplasmic reticulum, which we know houses all of the calcium, as you can see here. So sodium is going to come all the way through here, and it's going to come into these two receptors. So we have the DHP receptor and the RYR receptor, which is going to change the shape, which allows for the release of calcium from the SR. Okay, so, and as we know, once the calcium is released from the SR into the rest of the muscle, it's going to allow the muscle to contract. So calcium is going to be released from the SR, like I said, all throughout the muscle, everything like that. So then we come down to the two actin, or the two filaments in the muscle. So we have the thin filament, which is the actin, and then we have the thick filament, which is the myosin right here. So once this calcium is released, it's going to bind to this troponin right here on this actin filament. As you can see, there's this little thing that is blocking this myosin head from attaching to the actin, which causes the contraction there. This is called the tropomyosin. So once this calcium binds to the troponin right here, this tropomyosin will then be moved out of the way to where this myosin head right here can attach to this actin. So once this myosin attaches to the actin right here, it's going to pull the actin inwards. So this myosin head is going to attach right here. It's going to pull inward, and then by the help of ATP, it's going to release. And then say you need another contraction, this next myosin head, or whichever one you want, will then attach to the actin again and pull it again, which is also called the power stroke. Okay, so then how do we get this muscle to release? Or not release, but like decontract, because as long as we have calcium in this muscle, it's still going to be contracting, right? So we need to figure out a way to get this calcium back into the SR so that we're not contracting all the time, because that would not be good. So we do this by the SERCA, which is also called the sarcoendoplasmic reticulum calcium ATPase. So this happens by the ATP hydrolysis. So the calcium is going to be moved back into the sarcoplasmic reticulum, which is not really normal. So we need the ATP to move it kind of against the concentration gradient back into this SR. So once these calcium ions are moved back into the SR, it leaves less amount of Ca2 out here, the calcium out here, which, as we know, as this in the muscle, calcium is lower in the muscle, it allows this to not contract, right? So we're going to try to move all this back against the concentration gradient in to the SR, which allows it to relax. So that's basically a quick overview of the excitation contraction coupling.